Denture-base resins. Polymerization reaction. Polymerization occurs through a series of chemical reactions by which a polymer is formed from a large number of molecules known as monomers. Types: condensation polymerization, addition polymerization, condensation polymerization. Condensation resins are divided into two groups. Polymerization accompanied by repeated elimination of small molecules. Polymerization in which functional groups are repeated in polymer chains. The mers are joined by functional groups. Physical stages of polymerization. Polymer-monomer ratio 3:1 by volume or 2:1 by weight. Sandy. At this stage, the polymer powder is wetted and dissolved by the monomer. The mix exhibits a sandy consistency during this stage. Stringy. The mix becomes a sticky mass and forms strings when manipulated. Dough. Mix becomes a workable mass of dough consistency. The dough stage is the working stage of the resin. Termination of stage 2 and starting of stage 4 is the working time. 5 minutes of dough moldability is considered to be the adequate working time. Rubbery, elastic. Following the dough stage, the mass becomes resilient and rubber-like. Stiff. This stage ensues when the curing cycle is completed. Chemical stages of polymerization. Induction. Induction is the process of activation of free radicals which in turn initiate polymerization. Methods of activation. Heat activation. Application of heat may dissolve the initiator benzoyl peroxide to release the free radicals, which occurs rapidly between 50 to 100 degrees Celsius. Chemical activation. The tertiary amine provides the free electron. When mixed together with benzoyl peroxide, initiator, starts the polymerization reaction. Light activation. The photons from a light source activates the initiator to release free radicals which initiate the polymerization process. The photoinitiator is camphorquinone. Propagation. Propagation of the reaction occurs with the initiated free radical molecule approaching other free radical molecules, and the free electrons interacting to form longer free radicals. Theoretically, the reaction continues until the monomers are converted to polymer. Practically, polymerization is never complete and hence some amount of monomer is always present. Chain transfer. In this process, the active free radical of a growing chain is transferred to another non-reactive molecule and a new active free radical for further growth is created, resulting in a new nucleus for growth. Termination. Direct coupling of two free radical chain ends or by exchange of hydrogen atom from one growing chain to another is the cause of termination of the polymerization reaction. Composition of heat cure resins. Powder, poly, methyl methacrylate, major component. Ethyl or butyl methacrylate, copolymers improves properties. Benzoyl peroxide, initiator. Compounds of mercuric sulfide, cadmium sulfide, etc. Dyes. Zinc or titanium oxide, opacifiers. Dibutyl phthalate, plasticizer. Inorganic fillers like glass fibers, zirconium silicate, alumina, etc. improves physical properties. Liquid, methyl methacrylate, major component. Dibutyl phthalate, plasticizer. Glycol dimethacrylate, cross-lining agent. Hydroquinone, inhibitor.